Hello, everyone. Welcome to the Code to Cloud event. This panel here is a bunch of experts here going to riff and talk about working together with shifting left for security, the Nirvana. This is a great event. Brian Ross, Head of Technology Products at Sky, Leif Tressler, Engineering Manager, Security Features at Segment, and Shannon Leitz, VP of Vulnerability Labs at Adobe Security. Thanks for joining me on the panel. Thanks for coming on.
Thanks for having us.
Thank you. I'm super excited to be joining everyone today to be talking about how we can make security awesome with DevOps.
My name is Guy Eisenkrank, and I'm a Senior Director of Product Management for Bridgecrew, now part of Prisma Cloud by Palo Alto. My session is going to talk about you can't secure what you can't see, discussing the complexity of securing supply chains.
Welcome to the session on security versus delivery and how you can win with something called dependency inversion.
And today we're going to talk about authorization as code, kind of a modern perspective on how to go into access control and authorization, and specifically focus that into the business aspects and how we can leverage existing tools, existing best practices, and existing open source solutions so we can make our products, applications, and organizations more secure and more easy to use and connect.
Today, I will talk about how Yap has implemented least privilege compliant access control across different systems and how we are ensuring to keep these systems least privilege compliant.
Hi everyone, thanks for joining. Good morning, good afternoon, good evening, depending on where you are. My name is Stephanie Chaplin. I'm a solutions architect at GitLab, and today I'm going to talk to you about securing DevOps, where to start, and what to measure.
Hello, and welcome to this session. This is Security as Code, a DevSecOps approach.
Welcome to the Road to Resilience, Chaos Engineering, Game Days, and Disaster Recovery. I'm really excited to be here with you all today.
All right, welcome everybody to another session of Code to Cloud. My name is Jeroen Willemsen, and I would love to talk to you about how to nudge your secrets with our project Always Wrong Secrets.
It seems like the number of security incidents and data breaches are increasing. When there is a security vulnerability, we always blame the developers. They're the first one that we say. However, is it really the developers' fault? For this presentation, I'd like to share my opinion on this from an application security perspective.
Hi, I'm Tim Davis, DevOps Advocate with M0. I want to thank everybody for having me here at the event today. Really excited to talk to you about the pitfalls of infrastructure as code and how to avoid them.
Hi, welcome to Code to Cloud Summit. I'm so excited to share with you container scanning run fast and stay safe.
Hello everyone, welcome to the Kubernetes Code interactive Kubernetes learning playground. So today we will be looking at how we can look at Kubernetes security from going a code and building and deploying and running in the production clusters and taking feedback and improving them over the time.
Hey everyone, Alex Williams, founder and publisher of the New Stack, here for a wonderful conversation at the Code to Cloud Summit. Today we are talking about app security. Where does it end and where does cloud security begin? I want to just get started with a quick question.
I'm Emily Freeman. I'm the author of DevOps for Dummies and the co-curator of 97 Things Every Cloud Engineer Should Know. I am thrilled to be here with you all and discuss some interesting ideas.
I think in an ideal world, again, developers would have all the knowledge and all the tools necessary to develop applications which are secure first time around.
Yeah, I think the ideal end state is really just security being seen as a component of good software. And I think that is happening, and I think that maybe that's already true at a lot of organizations, but I don't think security should be seen as this esoteric body of knowledge that you need a security team to understand. It's really something that developers should be able to understand, and developers, generally speaking, want to build good software.
So to me, shifting left and the nirvana of it really means, and the ideal state of it is, getting to demonstrable security within all things, as security being a team sport. I don't think it's ever been really treated like a team sport, and it is essentially that. There are reasons why developers need to make more and more of the security decisions. They should be picking things out that are part of their security software or secure software. And their software bill of materials has to be something that they are prepared to talk to.
Here's the TLDR for today. We have talked about DevOps and security and why it's so relevant and why it's not just about doing security. It definitely helps us do security better, but it's also about making our work more sustainable and better for us. And then we talked about how to actually do it, right? So a few deep dives on how we can shift left. We talked about cloud architecture, the 5 key components, and how it makes a significant difference between elite performers and low performers, and how we can achieve cloud architecture, maybe even if we're not in the cloud. We talked about culture and how sometimes walking the walk makes us feel like we're in that culture. It actually helps us change the culture. And then we talked about how culture is a significant predictor of higher performance and the ability to develop and deliver code with higher speed and stability. Then we wrapped up by talking about productivity and how productivity isn't just going to be one metric that matters, and how productivity is really a combination of several factors that touch on the 5 pieces of space: satisfaction and well-being, performance, activity, communication and collaboration, efficiency and flow. We talked through a couple examples, one from incident management and one from the Good Day Project, which can give anyone key insights into their own day in just a 2-minute check.
Ask yourself, can I see my version control system? Do I know if my CI/CD configurations are hardened? Is my infrastructure as code vetted continuously? Does it deploy secure infrastructure through a state management automation utility like Kubernetes and Terraform? Am I tracking that process? Do the resources that get created ever get vetted post deployment? All of those questions need to be answered if you want to tighten up and enhance your supply chain security. We recommend creating a real-time attestation, something that reports all of those build artifacts into one place, all of those code artifacts, and then identifies which configurations eventually take effect in the deployment process. Put that all into one place, inventory that data. And then if you can, also visualize and identify the bottlenecks. If one misconfigured template for a Docker file is then used to CI/CD tasks that can then run secrets and API tokens that you use to deploy your application, you want to know that's going to happen and stop it before it does. Try to connect the dots between the image data, the infrastructure data, and your custom code, the packages that you use in order to introduce new features into your applications. All of that together eventually hardens and tightens your supply chain and makes you less vulnerable to the next phase of code, build, deploy, and run vulnerabilities that may get discovered in 2022.
If the question is, can I change my security tool or policy tomorrow without affecting delivery? And your answer is, I don't think I can, or it will be really difficult, maybe consider dependency inversion. As I mentioned before, dependency inversion is a way to abstract between low-level and high-level objects. Choose that abstraction. Era of multiple systems, clouds, platforms, providers, tools, abstractions are ways that we can invest time into future-proofing efforts that we have to make to change architecture and tools in the future. So choose an abstraction between low-level and high-level objects. And what's really neat about dependency inversion is the ability to share security practices and knowledge. I don't have to be an expert, perhaps, on network firewalls to understand the security practice of making sure that I don't have network access to everything, right? Dependency inversion and choosing an abstraction allows someone to communicate the kind of security practice they need to have, and for a high-level object or the person managing the high-level object to understand why it's important.
To bring everything together here, with all the capabilities we mentioned, let's see what kind of enabling for business we get out of this. So first of all, this enables us to be more compliant. We mentioned most compliance like ISO and SOC 2 and even GDPR, it's all about having access control and mitigation and checks and balances on how we manage things. So by building these solutions, we'll be able to be more compliant more quickly. By adopting policy as code and by leveraging it with open source solutions like this, we'll be able to shift left to developers and enable them to lead the charge. And as things are becoming more and more complex, especially around microservices, this is probably the right thing to do. By combining low-code interfaces or interfaces both for our customers and our back office, we'll be able to not only have the charge being led with the developers, but also enabling them to empower the rest of the organization. By enabling interfaces for our customers, we enable them to self-govern, so we don't have to tweak every little thing for them. So they can have their kind of small garden within what we're building, within the guardrails, and require less updates for features from us as we're building things for them. By adopting these best practices, we can avoid pitfalls. And lastly, by adopting these best practices and tools, we are ready for the future.
I would say that the consistent access logging across different systems is important to determine the usage patterns. The next one is that manual list privileging is not enough for dynamic environments. Access groups memberships can quickly change. And we recommend to not to wait for implemented auto-revocation system after implementing a new authorization system. Automated revocation can help maintain the least privileged groups way sooner. The next conclusion point I would like to make is that revoking access from users may be sensitive, so over-communicating is always good. Exemption lists, on the other hand, are good but not good enough. They can grow big quickly and become a least privileged problems themselves. So if you can avoid them in the first place, that's a huge plus in my opinion. And finally, we can conclude this talk by saying that automated revocation helps keeping least privilege across different systems, which leads to less risk and better security.
Take a security-first approach. Like I said before, imagine get to a point where like, wow, the security is so embedded, we couldn't even remove it. Like, where would we even start? Security's everywhere. So you want to, secure by design, etc. Break down silos. We are all on the same team. We're all working for an organization. If it's a startup or a larger one, like we don't want to be hacked or front page of the news. And finally, make it fun. Automate and measure your results. You want to empower your developers. You want to, especially with development, you have usually 100 to 300 developers for each security. Imagine if we could just make them like 1% better, or just empower them. Like, here are your scan results as you're coding, so you can fix bugs as you go, rather than receiving a long list of problems afterwards.
A good definition of security as code is the methodology of codifying security and policy decisions and socializing them with other teams. Okay, so there's a lot in that definition. First of all, we have security experts, which are normally the security engineer within your organization, which are codifying security and policy decision. So codifying means that they're writing code to express those security and policy decisions. Do that in code, by coding those requirements, developers are going to be able to read them, understand them, and even contribute back to them. And that's part of socializing those practices and decisions. It's not just about handing those requirements away anymore. When everyone can participate, all of a sudden the responsibility is on everyone in the organization. We say so often that security is everybody's job, but we don't provide enough context for everybody to do something about it. And security as code is one way to provide at least more people context of what's going on.
When we talk, reliability is no accident. And if there's anything that we've learned over the years, we've learned that reliability takes work and a plan and strategy and a lot of tactical actions, which include that teamwork and collaboration. And so I want to talk about how you can make your systems more reliable and how everyone can work together to improve reliability.
Can you keep a secret? Well, that's actually a major question we've been having throughout years, I guess centuries, or even, ever since humankind got to existence. That has become much harder when we talk about technology. So how can we make a computer keep a secret? And more importantly, how can we make sure the secret doesn't get revealed to those who shouldn't be able to get there? AKA, how can we keep it confidential? That's not that easy, and I'll show you in a moment why that is the case. Apparently, secrets management is just not that easy. It's kind of special, as we like to call it. Well, we are people from InfoSec, so we call everything special, right? So is this really a problem, or isn't it? So therefore, we created a project, OWASP project Wrong Secrets. With this project, we hope to educate you about how to not store your secrets and give you a few hints and tips on how to do it properly, together with other projects within OWASP, like the cheat sheet series and other things.
Software development has come a long way in the last 20 years. We're now able to deliver a lot faster due to the scaling challenges. And given that most organizations have more developers than testers, we're shifting a lot more responsibilities into the developers. We're no longer building our systems from the ground up. Instead, we're assembling them using open source components, and they're written by someone else. And as such, staying secure is hard. There's a higher likelihood of introducing vulnerabilities or misconfigurations into your systems, and it's not always your developer's fault.
Security is not just an afterthought. And of course, in the past, it has been, simply because when you're deploying stuff, when you have your development sandboxes, security doesn't really get involved until you take that app and you want to promote it to production. Now, this can cause a lot of big issues with infrastructure as code, simply because you don't necessarily have the same structure, the same setup, the same rules. Bringing security in to check all of your infrastructure during the process is going to help you out. There's a lot of security tools out there that can help you shift left with that. Check off by Bridgecrew. We've got Terrascan by Accurates, an open policy agent as well in there. A lot of these static analysis tools can help you bring security closer into the development process, so that if you do have an issue, you can take one step back instead of maybe 5 to 10 steps back later, or figuring out that you have an issue that's already in production and has already been compromised.
Kubernetes is good at protecting itself. The Docker hypervisor is good at protecting itself, but it doesn't protect the content running inside of our containers. We need to use container scanning to accomplish that process. Container scanning is a great way to be able to understand the vulnerabilities in our system and to be able to take corrective actions quickly.
If you're someone coming as an attacker or red team, you can use Kubernetes Code as a project to learn how we can attack and find security issues in a modern ecosystem, from deploying code to going into the production clusters, and find some of the ways how you can bypass and exploit. And if you're someone coming from defenders and blue teams, right, who is securing, you can use these logs and Kubernetes Code attacks to detect and build monitoring systems, to build detection platforms, right? So this is a ton of value which you can get out of the project. And if you're someone like Palo Alto, Bridgecrew, or any other vendors, right, definitely they can leverage these kind of open source projects to test their effectiveness of the tools, right? We just saw Bridgecrew detected 232 issues in the Kubernetes Code project. Similarly, tools like Twistlog or any other vendors as well can leverage these tools to see how much security issues can be detected and improve the product effectiveness, and also building the community of security around Kubernetes by contribute back to the Kubernetes Code as well.
There was this discussion about app security, and the comment came across, app security really hasn't changed at all over the past 10 years. Do you really believe that?
I may have a bit more stronger opinion on why it hasn't changed. I definitely feel some of the components of application security has let's just say people have gotten accustomed to having a lot of false positives as a default, as a normal when dealing with application security. And by what that I mean is, if you say, people talk about code security a couple of different ways. They talk about education for developer security, and they talk about the tools that comes with it. And I guess the question of evolution is more around the fact that the tooling itself hasn't changed. We're still working on educating people, which is a great thing. And it's a slow progress, but it's working. But on the tooling side, I definitely feel as security professionals, and I used to count myself in there as well, is that we really haven't evolved to the point as, say, something like a infrastructure as code security is going, or cloud security is going as well, because we still deal with false positive in a SaaS world.
But I think that's where maturity model comes in. In order to remove all those false positives, you need to mature your SaaS tools that you're actually onboarding to remove all those false positives. So there are 4 levels of DevSecOps maturity. So maturity level 1 is by using a tool as is. That's where you find so many false positives. So when you're maturing towards maturity level 4, you find less and less maturity levels. You find less and less false positives. So that's why I'm saying we're quite keen in having it there for some bit of time, as long as you're keen as well as an organization to mature the SaaS tool that you're onboarding.
I think if you stop at findings, that's when we're going to swim in an ocean of false positives. I think the evolution that I'm seeing in AppSec world is every finding comes with a context, the root cause analysis of where the actual problem lies. And if we chase that down, then the whole class of vulnerabilities just disappears, right? I think the tools are getting slowly better in identifying the root cause analysis. At the end of the day, as security professionals, we want to reduce risks in our code. And whatever that drives that good behavior, like what Joylin was mentioning, is essentially what is going to help us mature in our security programs.
Securability is represented as a single spoke in the revolution model, but it emphasizes accountability because it crosses every role we take on throughout the development process. Everyone from architects to operators is responsible for the security of the system. Testing too. But it goes further than that. There is no beginning and end in software anymore. I guess you could go out of business. Don't do that. But beyond that, you are responsible for your ever-aging software. The security of the system must be reliable. Trust is something slow to build and quick to lose. We all know it only takes one misstep to permanently mar the reputation of a business. Developers should have visibility into various aspects of security. The stance, decisions, scanning, risks, everything. When you obfuscate those aspects or make decisions behind closed doors, you create confusion, suspicion, and fear. It's no wonder at that point that people would blame security for, well, everything. I talked about compromising earlier and building some kind of level of flexibility into your system. On a windy day, a skyscraper can easily move a couple feet in any direction without undermining its structural integrity. Security needs to be like that, strong, but not brittle. I can't tell you how you need to be flexible, but talk to your team, find out what works for them. And if you're unsure, experiment. Make sure harm is reduced, but don't be afraid to take small risks. All of this enables you to scale the security of your system across people and departments. In-groups and out-groups will always exist. We are humans. Two forces pull at us constantly, the desire to belong and the need to stand out. And the more that you empower people and create opportunities for growth, the stronger your security stance will be. Our technical systems exist in a social system, and it's culture that ultimately determines your success. Thank you.